Welcome everybody to our fluid mechanics experiment. We are Seban, Daniel Luzzatto, and Sharon Atlan. As we dive into our experiment, assumptions are key. We considered the flow to be constant and laminar friction to be present and the flow to be irrotational and incompressible. Now let's take a closer look at the theoretical basis of our experiment. A cylinder is rotating counterclockwise through constant flow. The Magnus force is the force created from the pressure difference on the surface of the cylinder pushing it to the right. Building upon this concept, we've looked for a closed formula for the Magnus force. Starting from the flow equations, we found the pressure and incorporated it into the Magnus force formula. After some integration, we've successfully obtained a precise expression for the Magnus force. To visualize the forces acting on the system, we've analyzed a free body diagram showcasing the interaction between the Magnus force and friction on our custom cart cylinder system. Applying Newton's second law and assuming constant flow and angular velocity, we found the acceleration of our cart cylinder system. Now we collected some data. We determined a flow velocity of the blower to be 3.46 meters per second by throwing a piece of paper in front of it and measuring its speed with tracker. We've also extracted the angular velocity measured at 20.944 radians per second. Additionally, our experiment's accuracy was aided by a custom circuit featuring essential components like a diode, resistor, transistor, 9 volts battery, and the STM32 microcontroller. With an emphasis on precision, we've calculated the position and velocity of the cart, obtaining valuable insights into the motion. Our calculations enabled us to derive the acceleration as a function of time. Pooling data from both tracker and the accelerometer, we've harmonized our findings to achieve a final acceleration value of 0.188 meters per second squared, revealing the effects of the Magnus force and friction. Let us compare the theoretical values from our calculations with the real-world results. This analysis has unveiled the role of friction within our dynamic system, highlighting its impact.